Hello and welcome. This week we are talking about economic minerals and human health. So how all of the science and theory we've been talking about this semester applies to possibly your future career, but definitely your everyday life. So let's get started. Economic minerals and human health. So up until this point, we have classified rocks and minerals based on how they formed, either igneous, sedimentary, or metamorphic, right? And that's probably how you've done it all the way through your schooling. So that's it. We're done, right? Well, that doesn't include how each of these materials impacts us as humans, right? So we're not just looking at these for the sake of science, we're looking at these materials for the sake of their economic and societal importance, which we've been talking about all along, but we're really going to focus on today. Also keep in mind that because we are talking about how materials form that are economically important, we're also talking about where we choose to mine, and this will be very helpful in your mining game. So as we're going through the topics today, keep thinking back to your mining game. All right, so many of these minerals that are of economic importance, like native elements, like gold and silver, also sulfides and other gem materials, things like that. Many of them are of economic importance, and we call them industrial materials, right? They're used in society economically, so we call them industrial materials. Ore materials are those materials that contain these industrial minerals, such as metals, that we are going to be mining. Now, the origin of industrial minerals, there's a few different ways these minerals can be formed, but most commonly we find them either in hydrothermal veins or in pegmatites. So hydrothermal veins, think back to when we were talking about igneous minerals. Hydrothermal deposits are the result of the precipitation of ore in fractures, faults, any open space that is filled with some fluid that contains a lot of dissolved ions. And really hot fluids can hold way more ions than cold fluids. So the spaces that are filled with hydrothermal fluids, meaning fluids that are really hot because they're inside the earth. So think like 50 degrees to 700 degrees Celsius. These are the ones that are going to deposit a lot of those economically important minerals inside of those, the faults, the cracks, the open spaces, creating these important economic hydrothermal veins. Right? You might have seen pictures that look like this, right? Where you get that beautiful gold deposit inside a crack within another rock. So that's going to be a hydrothermal vein there. Now, the second place that we often find these economic minerals is in pegmatites, and pegmatites are just exceptionally rich or exceptionally coarse-grained igneous rocks. So again, igneous processes are super important. Heat is really important here. So anytime you are able to create an igneous rock that cools so slowly that the grains are able to get very, very, very large, like unusually large, like, larger than a few centimeters. We call those pegmatites. And they're often found in dikes, lenses, veins, batholiths, things like that. And they represent the last and most hydrous portion of a magma to crystallize, right? It's that part of that magma that cooled so slowly. It was the last to crystallize. So it has really, really high concentrations of minerals that were excluded from those first crystals. Right? Think Bowen's reaction series.